Hello dear students, welcome back to the lecture number 2 of gravitation. Okay, so last time हमने पढ़ा था superposition principle and in this lecture we are going to do some questions on the superposition principle. Okay, so have a look. This is our question number 1 which we are going to do. Question number 1 is like this. There are three particles at the three corners of an equilateral triangle. So this is the equilateral triangle. And there are three particles at the three corners of equilateral triangle. This is M, M and M. Okay. Now the question is that calculate the net force on particle at point P. So we are supposed to calculate the net force on this particle, which is at point P. Okay. So how many forces are there on this particle, which is at the point P? There are obviously two forces on this particle. One force is due to this particle and another force is due to this particle. All right. Okay. तो इनका वेक्टर डायग्राम हम बना लेते हैं. Let me make the vector diagram of this. So one force is along this direction. Another force is along this direction. All right. Both are attractive in nature. Both the forces are attractive in nature. This is another force. Now can you tell me what is this angle equal to? Obviously इक्विलेटरल ट्रायंगल है तो इसका मतलब ये एंगल जो होगा इट विल बी 60 डिग्री. Now whenever angle is equal to 60 degree, the resultant of these two forces will be along the angle bisector, and that resultant will be equal to what? That will be equal to root 3 into f. Okay, which means that the net force on the particle P comes out to be root 3 into f. ठीक है जी. So F is the gravitational force between two particles, which is equal to G m1 into m2 divided by r square. So mm is m square divided by a square. This is the net force on the particle at point P. In fact, this is the force on this particle also, and this is the force on this particle as well. Okay, simply there are two forces on this particle P, and the resultant of those two forces is root 3 into f because angle is 60 degree, and f के बदले मैंने क्या insert वहाँ पे किया, that is gm square divided by a square. See another example. So this was question number 1. Let's try to do question number 2. Have a look. This is our question number 2. So the question number 2, it's a right angle triangle, and in this right angle triangle we are supposed to calculate the net force on this particle at the point P. So let me name this particle as this point as point P. All right. Now how many forces are there on this particle? इस particle पर कितने force हैं? There are two forces on this particle. One force is along this direction, which is equal to F, and another force is in this direction, which is also F. Now you tell me what is this angle equal to? What is this angle equal to? It is 90 degree, isn't it? When it is 90, so that means the resultant of these two forces will be along the angle bisector, and it will be root 2f. ठीक है जी. Whenever angle is equal to 90 degree, the resultant of two forces of equal magnitude is root 2f. That too along the angle bisector. So let me write down here the net force on the particle P is equal to root 2 into f. ठीक है जी. तो root 2 के बदले मैंने लिखा root 2, and f is the gravitational force between m and m, so that comes out to be g m square divided by a square. This is the gravitational force on the particle P. On the particle P. So this is the answer to this question. I hope that it is clear to you. This example is also clear to you. These examples will be definitely repeated in electrostatics, and not only in electrostatics but also in gravitation, in magnetism. ठीक है जी. Let's do another example. This example number 3. Now we have to calculate the net force on the particle P. Again, how many forces are there on the particle P? यहाँ पे आप थोड़ा सा ध्यान रखेंगे. There are 3 forces on the particle P. Force number 1 is due to this m, another force is due to this m, and third force is due to this m. So how many forces are there on this particle? there are three forces on this particle. Let me first and foremost show the direction of those forces. One force will be along this direction, isn't it? It is attractive in nature. Another force will be along this direction. Again, this is attractive in nature. And the third force is diagonally along this diagonal direction, like this. It's in this direction. Okay, it's in this direction. But I will not name this force as F. The reason is that जो ये वाला force है, force between this and this particle, and force between this particle and this particle is same. The reason is that the mass of the two particles is same, and the separation this A and this A is also same. But have a look, अगर ये side इसका A होगा, this side is equal to A, this diagonal will not be equal to A, isn't it? This diagonal will be rather equal to, it is root 2A. So that means ये वाला force जो है, force number third, it will not be equal to F. It will be equal to, let me name it as F dash, which is different from the F. ठीक है? Now how many forces are there on the particle P? There are obviously three forces on the particle P. F, F and F dash. Now can you tell me what is the angle between this F and this F? Obviously 90 degree. When it's 90 degree, what is the resultant of F and F? That is root 2F along this direction, along the angle bisector, that is root 2F. Okay, so there are three forces on the particle P. Out of the three forces, I have calculated the resultant of the two forces. ठीक है जी. अब जो दो forces वहां पे हैं, कौन कौन सा force? root 2F and this F dash, since they are in the same direction, exactly like this. This force is root 2F, which is the resultant of F and F, and this is the third force, which is F dash. They are in the same direction. Whenever two vectors are in the same direction, they will simply add. So the resultant force on the particle P will be equal to root 2F plus F dash. Root 2F plus F dash. Now let me first of all write down this. What is the value of this F and what is the value of this F dash? F is the force between two particles whose mass is m and m. So it will be gm square. And the distance between those two particles is a. So I will write down here a square. ठीक है जी. F जो है, it is the force between this particle and this particle. So mass is m and m, and see the distance, that's equal to a. Alright. F dash is the force between two particles whose mass is m. So let me write down here gm square. But the distance between those two particles is not a. That is root 2a whole square. That distance is root 2a. Okay. It comes out to be gm square divided by root 2 square is 2a square. Alright. Now what I will do is that I will put these two values, this value and this value, in this equation to get the net force on the particle P. Let me write that down here. So the net force on the particle P will be equal to, root 2. Wait a moment. Let's write down that here. So net force on the particle P will be equal to what? It will be equal to root 2 into F. So F will be replaced by what? It will be replaced by gm square divided by a square plus F dash, and F dash will be replaced by gm square divided by 2a square. ठीक है जी. क्या आप मुझे बता सकते हैं इन दो इक्वेशंस में, इन दो टर्म्स में, what will be common there? That will be gm square divided by a square common आ जाएगा, and we are left with this root 2 plus 1 by 2. So this is the final answer to this question. Okay, and a very important question. ठीक है जी. This question has been asked a few times in JEE maths. So I am sure that this is clear to you. ठीक है. In electrostatics, अगर आप यही क्वेश्चन करोगे electrostatics में, तो answer will be I can write down that here. In electrostatics, the question is exactly same. In electrostatics, the answer will be something like this. The net force on the particle P will be equal to G will be replaced by K, where K is electrostatic constant. M square के बदले में क्या लिख सकता हूँ, Q square divided by A square multiplied by what? Multiplied by root 2 plus 1 by 2. This will be the answer to the question in electrostatics. That is why I am saying that we are trying to kill two birds with one stone. That's both electrostatics as well as gravitation. In fact, if gravitation is clear, almost like 60-70% of the electrostatics is also done. Okay, let's switch to another question. Have a look at this question. तो ये question आप देख लीजिए बेटा. This is example number 4. तो एग्जाम्पल नंबर 4 में आपको करना क्या है, आपको कैलकुलेट करना है नेट फोर्स ऑन द पार्टिकल एट द सेंटर ऑफ दिस स्क्वायर. तो सेंटर ऑफ द स्क्वायर पे एक पार्टिकल है, उस पर आपको क्या कैलकुलेट करना है, नेट फोर्स. ठीक है जी. ओके, तो देख ले आप. फर्स्ट एंड फॉरमोस्ट दिस मास इज 2m एंड दिस मास इज m. So 2m will attract the particle of mass small m and m will also attract. Okay, so there will be one force. यहाँ पे ध्यान रखिए आप बेटा, कॉन्सेंट्रेट ऑन दिस. एक फोर्स तो इस दिशा में होगा, दूसरा फोर्स इस डायरेक्शन में होगा. ठीक है, तो इसकी वजह से 2m की वजह से मान लो फोर्स है 2f एंड बिकॉज ऑफ दिस m द फोर्स इज f. So 2f minus f will be equal to f. So the net force in this direction will be f, which is the force due to 1m. All right. Then इसके बाद हमारे पास यहाँ पे पार्टिकल है बेटा 4m और यहाँ पे पार्टिकल है 3m. 4m minus 3m is again equal to m, which means that the net force on this particle will be towards 4m. And that force will be equal to what? That force is also equal to what? That is equal to f. That's also equal to f. Okay, now have a look. The angle here, that's equal to 90 degree. This angle is 90 degree. When the angle is 90 degree, you know that the resultant will be along the angle bisector. That too equal to what? That too equal to root 2f. तो ये वाला फोर्स जो होगा इट विल बी इक्वल टू रूट 2f. ओके, क्लियर और नॉट? फर्स्ट एंड फॉरमोस्ट वी कैन डायरेक्टली से दैट दिस 2m minus m is 1m. 4m minus 3m is equal to m. So the net force of this f and f will be root 2f. The reason is that the angle here is 90 degree, isn't it? Okay, now I will write down here the net force on the particle. Net force on the particle of mass small m comes out to be root 2 into f. Now what is the value of this f? The value of this f is g capital M small m divided by r square. And what is this r? This r is the distance between the center and the corner, center and the vertex of this square. Okay, now if for example this a is given to you, r is not given, this a, which is the side of the square, that is given to you. Okay, can we write down this r in terms of a? Yes, of course we can write down that this r is equal to, आप याद रखेंगे इसका वैल्यू होता है a divided by root 2. r is always equal to a divided by root 2. What is a? A is the side of the square. And what is this r? R is the distance between the center and the corner, and the relation between the two is this, that r is equal to a divided by 2. Okay, all right. ठीक है जी, ठीक है जी. So let me write down here this is here root 2 multiplied by g capital M small m divided by r square की जगह हम लिख सकते हैं a square divided by 2. Okay, now this 2 goes the numerator, तो ये बन जाएगा बेटा 2 root 2 multiplied by g capital M small m divided by a square. So this is the net force on the particle of mass small m. This is the answer to this question. Okay, I am sure that this problem is crystal clear to you. Again, an important question. Let's move to the another question. Let's move to this another question. This is a series of questions like this. अब क्वेश्चन है क्या, देख ले आप. क्वेश्चन नंबर, एग्जाम्पल नंबर 1 is, first of all, there are 3 identical particles placed at the 3 corners of an equilateral triangle. At the centroid of this triangle, another particle is placed. Like this, 3 particles at the 3 corners of an equilateral triangle, and another particle is placed at the center. In this in the example number 2, there are how many particles? 4 particles placed at 4 corners of a square, and the fifth particle is placed at the center of this square. Exactly in the same way, this one, there are 5 particles at 5 corners of a regular pentagon, and the sixth particle is placed at the center of this pentagon. In this example, there are 6 particles placed at the 6 corners of a hexagon, and the seventh particle is placed at the center. We have to calculate what is the net force on the particle of mass small m, which is at the center of this regular polygon. The answer is obvious, and that is 0. That is 0. Okay, simply by symmetry. By symmetry, we can say that the net force. Have a look at this question. Have a look at this question. So the force on this particle along this direction will be F, and the force along this direction will be again F. They are equal and opposite, they will cancel each other, isn't it? Then the force number 3 on this particle is along this direction, which is F. There will be one more force along this direction, which is equal to F. Again, they will cancel in pairs, hence net force will be equal to 0. The same logic applies to each of these, which means that the net force on the particle is equal to 0. Let me write down here. Net force on particle at center of polygon is 0. Okay, is 0. नेट फोर्स इन द पार्टिकल एट सेंटर ऑफ पॉलीगन इज इक्वल टू 0. ठीक है जी. तो आप याद रखेंगे, वेन एवर देयर आर n identical particles placed at n corners of a regular polygon, that regular polygon can be an equilateral triangle, that can be a square, that can be a regular pentagon, that can be a regular hexagon. When I say regular implies that a polygon whose each side is same and whose each angle obviously that's also same. So whenever we place identical particles, n identical particles at n corners of a regular polygon, the net force, gravitational force on a particle at the center of polygon is 0. आप याद रखेंगे, this is an important point. So simply in each of these examples, the net force on the particle at the center of the polygon will be equal to 0, because the resultant of those forces will be equal to 0. Okay, here we have another type of examples on the superposition principle, and that is circular motion in gravitation. Again, important questions have been asked in the JEE mains, okay, on this very topic, circular motion in gravitation. Let's try to crack this question. Okay, तो देख ले बेटा आप, क्वेश्चन है क्या, देयर आर 3 particles placed at 3 corners of an equilateral triangle, and because of the gravitational force they will move in the circular path, and we have to calculate the orbital velocity of the particle. From the orbital velocity we can in fact calculate the time period of these particles also. Okay, so how can we do that? What is the procedure of doing this sort of problem? Simply आपको करना क्या है, try to calculate the net force on one particle, net gravitational force on one particle. That net gravitational force on one particle will provide the necessary centripetal force. That is the procedure of solving such a type of question. Okay, so what I will try to do is that I will try to calculate the net force on one particle. Okay, let's try to calculate the net force on this particle. तो इस पार्टिकल पर कितने फोर्स होंगे? ऑब्वियसली देयर विल बी 2 फोर्स ऑन दिस पार्टिकल, one force along this direction and another force will be along this direction, and the angle is 60 degree, which implies that the resultant will be along the angle bisector, which is directed towards the center of the circle. That is essentially what we want. Okay, so there are 2 forces on this particle, one force along this direction, this force is F, another force will be in this direction, and this force is also equal to F. Now can you tell me what is this angle equal to? Obviously it is 60 degree. The angle here that's equal to 60 degree. When it's 60 degree, that means the resultant of these 2 forces will be along the angle bisector, and वो force कितना होगा? वो होगा √3 multiplied by F. ठीक है जी? Okay, let me first of all try to calculate what is this net force on the particle, net gravitational force on the particle, on one particle, that's equal to what? √3 into f. So it comes out to be root 3 into f के बदले हम क्या लिख सकते हैं? We can write down gm square divided by the distance here is a square. Okay, the distance between this particle and this particle is equal to a, or this particle and this particle is also equal to a, where a is the side of the square. Okay, now next what I am going to do is that I will write down the equation that this gravitational force will provide me what? It will provide me centripetal force. It will provide me centripetal force. Is that clear? Now gravitational force, we have just calculated that root 3 gm square divided by a square equal to centripetal force. Equation for centripetal force is always mv square divided by r. Okay, so the equation for the centripetal force is mv square divided by r. Mv square divided by r. Okay, now obviously this 1m and 1m is going to cancel. I can write it like this, root 3 into gm divided by I will replace this a square. देख लें बेटा, जो r है, r का वैल्यू होता है it is equal to a divided by root 3. r is the distance between the center and the corner of equilateral triangle. A is the side of this equilateral triangle. R is equal to a by root 3. Okay, तो मैं यहाँ पे क्या करूँगा? I will replace this a. So a will be equal to root 3 into r, because in this question the radius is given to me, the side of the triangle is not given to me. तो a square के बदले में क्या लिख सकता हूँ? A square will be simply equal to 3r square. That's what I'm going to write down here. So a square is equal to what? It is 3r square is equal to v square divided by r. V square divided by r. In fact, this 1r and 1r is going to cancel, and we are finally left with this velocity square, which is equal to root 3 divided by 3 is gm divided by root 3 multiplied by r. This is v square, isn't it? The gravitational force is root 3 gm square by a square, and the centripetal force is mv square divided by r. फिर मैंने क्या किया? I have replaced this a by root 3r or a square by 3r square. Then this root 3 by 3 is equal to 1 by root 3. Rationalization. तो v का जो फाइनल वैल्यू आएगा that will be simply equal to square root of what? It will be square root of gm by root 3 multiplied by r. This is the velocity of this particle, of one particle, which we call as orbital velocity. So this is the orbital velocity of one particle. I hope that it's clear to you. Now if you want to calculate time period, you can easily calculate that. Time period is simply equal to, that is circumference of the circle, which is 2 pi r divided by the orbital velocity v. Okay, you can write down that easily. That is 2 pi r divided by square root of all this gm divided by root 3 into r. Okay, so we are done with both. We have calculated the time period as well. We have calculated the orbital velocity. Okay, so done with this question. Let's switch to another example. Another question is like this: calculate orbital velocity of each particle again. So this another important question again, very important question. There are 4 particles placed at the 4 corners per square. You can see that in the diagram. 4 particles placed at 4 corners per square. Now due to mutual gravitational force, all these particles are moving in the circular path like this. They are moving in the circular path. Okay, and we are supposed to calculate orbital velocity of each particle. Again, the procedure is same. Calculate net force on one particle. Equate that gravitational force to centripetal force, that is mv square by r. Play with that equation. Try to calculate the value of v. That is how we actually do it. Okay, can you tell me one thing? How many forces are there on one particle? इस एक पार्टिकल पर कितने फोर्स है? How many forces are there? There are obviously 3 forces on this particle. One force is along this direction, which is F. We have done this question already. Another force is on this particle along this direction, which is again equal to F. Okay, and the third force on this particle will be along this direction. I will label that as F dash. I will label that as F dash. Wait a minute. I will label this force as F dash. Now what is the resultant of this F and F? That is root 2F along the same direction. along this direction there is this force which is root 2f, or root 2f, because the angle between f and f is 90 degree, hence the resultant comes out to be root 2f. All right, okay. Now f dash and root 2f are in the same direction, which means that the net gravitational force on one particle comes out to be root 2f plus f dash. ठीक है जी. एक बात आप यहाँ पे एक बात का ध्यान रखेंगे आप, that simply like this is what you call as diagonal of the square, isn't it? The length of this diagonal of square is always equal to root 2a, number one. Number second is that this is the half diagonal of the square, half diagonal. तो half diagonal का जो length होता है which is r, that's equal to a by root 2. ठीक है ना, some basic geometry. Now what's the value of this f? Fg is equal to root 2. This f will be simply equal to gm into m is m square divided by a square. Okay, plus f dash is the force between this particle and this particle, and the length of this diagonal comes out to be root 2a. So I will write it like this. It is equal to what? It is gm and m is m square divided by root 2a whole square. In fact, we have done this question already. Gravitational force will be equal to, कॉमन यहाँ पे जो आएगा वो आएगा gm square divided by a square, and we are left with this root 2 plus 1 by 2. Okay, now in this question the side of the square is not given to me, or that is the radius of the circle is given to me. This r is given to me and this a is not given to me. Can we write down this a in terms of r? Or of course we can write it down. R is equal to a by root 2, which means that this a is equal to root 2 into r. All right, which in turn implies that this a square जो है it is equal to 2r square. So let me put it here. So the gravitational force on one particle finally comes out to be gm square divided by 2r square into root 2 plus 1 by 2. This is the net gravitational force, and this net gravitational force is going to provide centripetal force, because each of these particles are moving in a circular path. So that means this net gravitational force will provide the necessary centripetal force. Gm square divided by 2r square root 2 plus 1 by 2, ये है net gravitational force. What is the equation for the centripetal force? That is mv square divided by r. Is there anything which is going to cancel? This m will cancel with 1m, this r will cancel with 1r. Okay, and we are left with this gm divided by 2r into root 2 plus 1 by 2 is equal to v square. So v will be simply equal to square root of all this. So this is what you call as the orbital velocity of the particle, of one particle. This is the orbital velocity of each particle rather. Okay, I hope that this question is crystal clear to you. Let's try to do some PYQ, some previous year questions of NEET and JEE mains based on this topic. तो देख लें आप जो नेक्स्ट क्वेश्चन हमारे पास है. दिस क्वेश्चन हैज़ बीन आस्क्ड इन JEE main 2021. Now what the question is exactly is that four particles each of mass capital M move along the circle of radius capital R under the action of their mutual gravitational force as shown in the figure. This is the figure. The speed of each particle is, we have to calculate the speed or the orbital velocity of each particle. तो क्वेश्चन हमने अभी किया है. लेट्स ट्राई टू डू दिस क्वेश्चन अगेन. तो देख लें आप बेटा. फर्स्ट एंड फॉरमोस्ट व्हाट आई विल ट्राई टू डू इज दैट आई विल ट्राई टू कैलकुलेट द नेट फोर्स ऑन one particle. So how many forces will be there on one particle? One force will be along this direction, that will be along this direction, and this force is F. Another force will be along this direction, this force is again F, this is F, this is F. And the third force on this particle will be along this direction, and what's that force? That is F dash. and f will make a resultant of what? Will make a resultant of root 2f in this direction. This is root 2f. And the net gravitational force on one particle will be finally equal to gravitational force on one particle comes out to be root 2f plus f dash. So it will be written like this: root 2. F is the gravitational force between two particles. It is G capital M, and capital M is capital M square, divided by, let's assume that the side of that square is equal to a square. ये वाला square जो यहाँ पे square बनेगा, this square, the side of that square is taken as a. That's what I am saying. Plus f dash is the force on this particle. F dash the force between these two particles. ये f dash का वैल्यू क्या होगा? It will be g m square divided by root 2a whole square. Eventually the equation comes out to be like this: gm square by a square into root 2 plus 1 by 2. This is the net gravitational force on one particle. Okay, is that clear? This will provide the necessary centripetal force required for a particle to move along a circular path. Okay, I will write down here gm square divided by. अब आप क्वेश्चन में देख लो, this a is not given to me. What is given is r. Now what is the relation between this r and a? Already we have written that down. तो r और a के दरमियान जो रिलेशन है वो ये है, r is equal to a divided by root 2, which means a is equal to root 2 into r, which in turn means that a square is equal to 2r square. Okay, so this a square will be replaced by what? It will be replaced by 2r square multiplied by root 2 plus 1 by 2. Centripetal force is m into v square divided by r. Is there anything which is going to cancel? Yes, of course, this m and m will cancel, and this r and r is going to disappear. And we are eventually left with the velocity. Let me write down here the velocity. Now the velocity comes out to be what? It is equal to square root of what? Square root of g m by 2r multiplied by root 2 plus 1 by 2. ओके, ठीक है जी m by 2r इंटू रूट 2. अब हम यहाँ पे एक कम करेंगे, थोड़ा सा क्रॉस मल्टीप्लाई, थोड़ा सा फर्दर सॉल्व करेंगे. दिस इज 2 root 2 plus 1 divided by 2. 2 into 2 is 4, so it comes out to be 1 by 2 into square root of 1 by 2 square root of gm divided by small r के बदले हम कैपिटल r लिखेंगे because that is given as capital R multiplied by 2 into root 2 is 2 root 2 plus 1. Okay, so this is the answer to this question, the final answer to this question. Okay, now which option is correct here? That is 1 by 2, that is this one, 2 root 2 plus 1. So option number A is correct answer. Okay, so this question has been asked in JEE Mains 2021, and I am very sure that this is absolutely clear to you. Okay, this is absolutely clear to you. Now this question is similar, question number 20, again asked in JEE Mains 2021. So the question is again for identical particles. Now the mass of each particle is given, that's equal to 1 kg, are made to move along the circumference by circle of radius is 1 meter. Under the action the speed of each particle. Let's do one thing. It is simply the same question, and in this question what is given is that the mass of each particle is 1 kg and the radius of the circular path is given, that's equal to 1 meter. Let's put it here. So the orbital speed simply becomes equal to what? It becomes equal to 1 by 2. I can write it like this. Rather. I'll insert here in this equation. इस equation में मैं put करूँगा. M is equal to 1 and R is equal to 1. So equation will be something like this. It will be something like this: G into M. M के बदले हम क्या लिख सकते हैं? 1 divided by 2 into 1 multiplied by root 2 plus 1 by 2. This will be the orbital velocity. Okay, तो आंसर फाइनली आ जाएगा v is equal to स्क्वायर रूट ऑफ क्या ऐसा कोई ऑप्शन है हमारे पास, g1 + 2/√2. yes, I can write it like this. further सॉल्व हम कर सकते हैं थोड़ा सा. so it will be g divided by 2 into 2√2 plus 1 divided by 2. ऐसा कोई ऑप्शन है इसमें, g/2, 2 2s are 4, 2√2 plus 1, 2√2 plus 1 divided by 2. इसमें थोड़ा सा एरर है, वो आप खुद देखेंगे. So the final answer will be something like this. I will write like this: 1/2 into square root of g into 2√2 plus 1. This is the final answer to this question. Okay, so what I can do is that 1/2 g into, या तो आप यहाँ पे लिख सकते हैं 4, this here 4, this here 4. Either you can write down here it is 4, or you can write down simply this is here 2 out of this root. Okay, तो आप खुद वहाँ पे ठीक करेंगे. तो क्वेश्चन नंबर 20 इज डन. अब आप देख ले क्वेश्चन नंबर नेक्स्ट इज दिस विच इज आस्क्ड इन JEE Man 2024. One more question, and again there are 4 particles. Again it's a 4 particle system. Let's try to solve this question also. So 4 particles of mass small m are kept at the 4 corners of a square. If the gravitational force exerted on one mass by the other mass is this, the length of the side of the square is. Okay, so again there this is a system of 4 particles like this. It is the system of 4 particles. Now we have done this question many a times. अब यहाँ पे एक पार्टिकल है आपके पास, that is m, and this another particle that is m, this another particle that's equal to m, and this another particle that's equal to m. All right. Okay, the length of the side of the square is, you are supposed to calculate the length of the side. This for example this a, and we have to calculate the value of this a. Now can you tell me what is the net gravitational force on one particle? We have calculated that many a times. That comes out to be what? That is now √2 plus 1/2 multiplied by g into m square divided by a square. Isn't it? This is the net gravitational force on one particle. Now we have done this multiple times. So 4 identical particles of mass m are kept at 4 corners of a square. If the gravitational force exerted on one of the masses by the other masses is this, the length of the side of the square is. Now let's try to do one thing, that is equate it with this. तो यहाँ मैं ये लिखूंगा बेटा, this gravitational force is twice √2 plus 1 divided by 2, क्रॉस मल्टीप्लाई यहाँ पे मैंने किया, gm square divided by a square. ठीक है जी. Now I will do one thing, I will equate this force with this because this is given to me, this is the force. Okay, so that's what I'm going to write down here is this, that is 2√2 plus 1/2 multiplied by gm square divided by a square is equal to the force that is given in the question, which is 2√2 plus 1 divided by 32 multiplied by gm square divided by L square. अब आप देख लें, you will have to calculate the value of A in terms of L. So straight away what I can write down is that this 2A square is equal to this 32L square, because this 2√2 plus 1 is equal to this 2√2 plus 1, and the gm square is equal to this gm square. So on comparison we can easily write down that this twice A square is equal to 32L square. 2 1 2 16, so A square comes out to be 16L square, which in turn implies that this finally A comes out to be 4 into L. So this is the answer to this question. Okay, this is the answer to this question. ठीक है जी. क्या हमारे पास कोई ऐसा ऑप्शन है that is A is equal to 4L? Yes, that is this. So the option number B is the correct answer to this question, and the question has been asked in JEE Man 2024. Okay, let's try to do another question, that is this question has been asked in JEE Man 2026. Let's try to crack this question. Okay, तो देख लें आप बेटा, there are 4 particles in the system as you can see in the figure. यहाँ पे 4 particles हैं इस सिस्टम में. कितने particles हैं? There are 4 particles, and the particles are given to us. this is m, this is another particle twice m, this is 3 times m, this is 4 times m. Okay, or placed at the four corners of the square as shown in the figure. The net gravitational force in the center of the square is found to be F1 when four particles are placed. So it is given to us that the net force on the particle placed at the center is equal to what? That is equal to F1. Now have a look. First and foremost, this 4m minus 2m is equal to 2m. And this 3m minus m is also equal to 2m. Which means that the net gravitational force, this will be the force because of this 4m and 2m. And this is the force because of this 3m minus m, which is also 2m. तो ये force अगर F है, this force is also equal to F, which means that the resultant will be along this direction of these two forces. And what that resultant is, that is root 2F. Why? Because this angle is 90 degree. Is that clear or not? Now this force is simply equal to F1. Let me write down this F1. This F1 will be obviously equal to root 2 into F. Root 2 F is the force because of let's suppose that यहाँ पे जो particle है at the center, that is small m. Now F is the force because of twice m. ये twice m कहाँ से आ गया? 4m minus 2m is equal to twice m. 3m minus m is also equal to 2m. So this force will be equal to what? It will be equal to G capital M, or rather twice m into small m divided by the distance from the center is r square. So this is F1. Let me rewrite it like this. F1 is equal to 2 root 2 multiplied by G capital M small m divided by r square. This is the initial force between on the particle placed at the center of the square. Now what is given in the question is that the force becomes F2. It is F2 when the positions of 3m and 4m are interchanged. And then it is given that F1 by F2 is equal to alpha divided by 5. And we are supposed to calculate the value of this alpha. Okay, let's try to do one thing, that is let me remake this diagram. Okay, so this is the diagram. ठीक है जी. अब देख लें बेटा क्वेश्चन में क्या दिया गया है. that 3m and 4m are interchanged. That means 3m mass अब यहाँ पे आएगा and this will be 4m. This particle has mass m and this one has mass twice m. Okay, now the net force on a particle at the center, for example जो center पे particle है that small m, वहाँ पे force है F2. Let's try to calculate that F2. See, have a look. This is mass 3m, this one is 2m, 3m minus 2m is m. So there will be one force on the particle small m, and that force will be, for example, it's equal to F1. It is equal to F, and that F is because of the m. Clear or not? Then अब आप यहाँ पे देख लें, ये वाला मास है बेटा 4m और ये वाला मास है m. 4m minus m is 3m. So which means that the force in this direction will be equal to not F. This F is because of m, and this will be 3F. Why I have written down 3F? The reason is that it is because of 3m. It is because of 3m. Okay, so the F2 will be eventually equal to this. जो ये F2 force है ये होगा, क्योंकि एंगल है यहाँ पे 90 डिग्री, but these two forces are not same. One is F, another is 3F. It will be rather equal to this. It will be equal to F square plus 3F whole square. Okay, because the angle is 90 degree. Now can you tell me what's the 3F square? That is 9F square, 9 plus F. So it is equal to simply equal to 10 into F square, or root 10 into F. Let me write down here, it is square root 10 multiplied by F. Okay, which is equal to square root 10 multiplied by F. तो F के बदले हम क्या लिख सकते हैं? We can write down G capital M small m divided by r square, where F is the force because of 1 capital M. So this is our force F2. I hope that this is clear. Now next what I am going to do is that since we have to calculate the value of alpha, let's divide the two equations. F1 divided by F2. Okay, so this is the value of f2 and this is the value of f1. This g capital M small m divided by r square is going to cancel. That will disappear and we are left with this. We are left with this 2 root 2 divided by root 10 divided by root 10. Is that clear? Now root 2 by root 10 is obviously 2 by root 5. That is 2 by root 5. That's 2 by root 5. Now it is given in the question that the value is alpha by root 5. So easily we can guess the value of alpha is equal to 2. So the answer to this question is that alpha comes out to be 2. Is there any option given that is alpha equals 2? There's option number A is correct. And this question has been asked in JEE 2026. That means this year only. Okay, so I'm sure that this question is also crystal clear to you. It's a bit complicated, but not undoable. Easily you can understand it. You people can understand it. Okay, let's switch to another concept, a very small concept but very important concept, and that is the point of equilibrium. Point of equilibrium. देख ले बेटा आप असल में है क्या? What the concept is exactly. There are two particles. हमारे पास दो particles दिए गए हैं. Two particles are given to us. This is one particle. Suppose it is m1, whose mass is m1. This another particle, इसका mass दिया गया है, that's equal to m2. All right. Separation between these two particles is equal to r. That is equal to r. Okay, that is equal to r. Now the question is like this. Where should we place a third particle? Where should we place a third particle so that it is in equilibrium? We have to locate the position of the third particle such that this third particle is in equilibrium. All right. Equilibrium simply means that the net force on that particle should be equal to what? That should be equal to 0, isn't it? Now, using your common sense, it's obvious. The third particle that should be placed somewhere between m1 and m2. Like this, that should be placed somewhere between this m1 and m2. This is m third particle. Why? Because there are two forces on this m. One force is due to m1. That force is direct towards left. And another force is due to m2. That force is directed towards right. Now there is a possibility that this f1 and f2 are equal and opposite, and they will cancel each other, and the net force on this small m is equal to 0. And hence we say that this particle of mass small m is in equilibrium. Now we have to calculate the value of this r1 and r2. Okay, so the answer to this question I will write down here. The answer to this question is that the third particle should be placed somewhere between m1 and m2, and obviously closer to smaller mass. So the third particle should be placed somewhere between m1 and m2 and closer to the smaller mass. We are supposed to calculate the value of r1 and r2. Can we do that? Easily we can do that. What we have to do is that equation number first I will write down is that this f1 is equal to f2. And equation number second is that I will write down this r1 plus r2 is equal to r. So we have two unknown variables and we have two equations. On solving these equations, we can finally get the value of r1 and r2. Let me write down directly the value of that r1 and r2. That r1 comes out to be square root of m1 divided by square root of m1 plus square root of m2 multiplied by r. And exactly in the same way, R2 will be equal to the square root of m1 will be replaced by square root of m2 divided by बाकी सब सेम होगा square root of m1 plus square root of m2 multiplied by r. Okay, we can easily solve these two equations and get the value of r1 r2, but eventually you will have to memorize these end results for the sake of problem solving. Okay, so this is the value of r1 and ये जो है बेटा this is the value of r2. Important, very very important. This is not important only for the gravitation but important also for the electrostatics. This equation will be repeated definitely in the electrostatics. Okay, और आप यहाँ पे एक ध्यान रखेंगे. Let me write down here the important point, that is if this m1 is equal to m2, then obviously if the two masses are same, then in that very case the point of equilibrium will lie at the midpoint, which means r1 will be equal to r2 will be equal to r divided by 2. And another important point here is that is r1 plus r2 is equal to r, isn't it? Which means that r2 can be directly calculated by this equation, r minus r1. Okay, we can directly calculate by using this equation r2. Let's do a couple of questions on this so that this concept becomes absolutely clear to you. Let's try example number 1 here. तो क्वेश्चन है simply locate point of equilibrium. That means we are supposed to calculate the distance of the point of equilibrium from m1 and m2. Locate point of equilibrium. Locate point of equilibrium. Okay, what is given is that two particles are given to us. Two particles are given to us like this. Here we have this one particle, mass m1. It is given to us, it is 16 kg. This is another particle m2. The mass of this particle is equal to 25 kg. The separation between these two is equal to 18 millimeters. Or wait a moment, rather I will write down 18, let me write down 18 meters. Okay, we will have to locate the point of equilibrium. It's quite obvious that the point of equilibrium will lie between m1 and m2 and will not be at the midpoint. It will be closer to m1. Now this distance is r1 and this distance is r2. Can we calculate r1? Easily we can do that. Let me write down here, this is r1 equal to r1 is equal to what? It is equal to square root of m1 divided by square root of m1 plus square root of m2 multiplied by r. Okay, now put the values. What is the value of m1? That is 16. So let me write down here root 16 divided by root 16 plus m2 is 25. So it will be square root of 25 multiplied by r. What is the value of this r? R is given to me, that's equal to 18. Okay, let's try to solve this. Root 16 is equal to 4 divided by root 16 is again 4 plus root 25 is 5 multiplied by 18. That's finally 4 into 18 divided by 4 plus 5 is 9. 9 1 9 2 2 into 4 is 8. So the answer comes out to be 8 meters. So 8 meters is the answer. That's r1. Now directly without applying this formula we can calculate r2. r2 will be equal to r minus r1. ठीक है जी. तो r का वैल्यू वहाँ से दिया गया 18 minus 8. 18 minus 8 comes out to be 10 meters. Comes out to be 10 meters. So that implies the value of this r1 is equal to 8 meters and the value of this r2 is equal to 10 meters. Now have a look that the point of equilibrium lies closer to the smaller mass. Let me keep a home assignment for you. This example number 2. I'm sure you can do this question. Again, there are two particles. Let's take this particle mass m1. It is 9 kg. This particle is M2, whose mass is equal to 49 kg. The separation between these two is equal. Let's take it 20 centimeters. 20 centimeters. Obviously, R1, R2 will be the centimeters. Point of equilibrium will lie somewhere in between. This is R1, this is R2. I hope that you can do this question easily. I will keep it as a home assignment for you. Okay, so next topic जो है that will be acceleration due to gravity. We are done with the topic number 1. जो topic number 1 हमारा था, that is so till now we are done with Newton's law of gravitation. Topic number 1, which is simply the gravitational force between the two masses is G m1 into m2 divided by r square, and we have done a good number of questions on this. Then next इसके बाद हमने क्या किया बेटा, we have done superposition principle. Superposition principle implies that the net force will be something like this. It is equal to F1 plus F2 plus so on and so forth, the vector sum of the forces. Okay. I'm sure that these topics are crystal clear to you, absolutely crystal clear to you. ठीक है जी. Let's stop here. Topic number 3 हम पढ़ेंगे lecture number 3 में. But before you say goodbye, तो एक चीज़ का आप ख्याल रखेंगे, that is stay concentrated with these lectures. They are highly important if you are preparing for the NEET and if you are preparing for the JEE mains. अब बहुत सारे स्टूडेंट्स आपके दिमाग में क्वेश्चन ये होगा, सर आप तो दिखा रहे हैं JEE मेंस क्वेश्चंस भी इसमें, सो आर दे इम्पॉर्टेंट फॉर द नीट? यस, ऑफ कोर्स दे आर इम्पॉर्टेंट फॉर द नीट. If you are looking at the NEET 2025 paper, then you will realize that these questions are important as well. Number 1. Number 2 is that just stay focused, just stay concentrated, and your feedback will be always welcome. I will try to improvise wherever it's required. So see you all in the lecture number 3. Take care.